In this video, I'd like to talk about the steps of hypothesis testing, the procedure of hypothesis testing. So first of all, it's very important to understand the difference between hypothesis testing and interval estimation of population parameters. When we're doing interval estimation, we're trying to find an estimate, either the point, 1 point or an interval for population parameters like population mean and population standard deviation and population proportion without having any pre-assumption, without having any claim about the value of these population parameters. Whereas when we're doing hypothesis testing, we're actually testing to see, we're actually checking to see if a statement about population parameters are correct or not. So that's the difference. Before, we just look at the sample and try to understand, try to come up with a range for which we could say with 95%, for example, confidence, we could say that the population parameter value belongs to that interval or belong to that range. Whereas in hypothesis testing now, we have a statement, we have an assumption about the population parameters that we are interested, were actually the one that is under study. For example, we might be testing to see if the population mean of a variable is equal to 1,000 or not, for example, right? So that can be now a hypothesis testing. So when you're trying to run a hypothesis testing, in general, doesn't matter what type of test you're doing, because this test, hypothesis testing can be done on different population parameters, and then the details might be different depending on what type of parameters that you're using, and also the type of the test. You may have one sample test or two sample tests or multiple sample type of test. But in general, these 6 steps should be completed for any type of hypothesis testing, regardless of, again, the number of samples, regardless of the type of population parameters. Now, what are these 6 steps? I'd like to first go through these 6 steps, and then we will talk about the first 2 more specifically. These are, again, more general. And then step 3, 4, 5, and 6, these are more specific to the type of the test, to the population parameter and the number of sample, the number of groups. So first, I'm going to focus, we're going to review all these 6, and then we will talk about the first 2 in separate videos. And then for the other steps, for step 3 to 6, we're going to do basically, we're going to review them for every type of hypothesis testing separately. So step 1 is to develop a null and alternative hypothesis. So again, in hypothesis testing, we're given a statement. We're given a statement, and the statement can be an assumption, a belief, a common belief about the value of the population parameter, or it can be a claim. It can be something that we want to basically test. We may have a research question, we may have a claim, and we want to be really conservative about it. So in that case, we put it in the alternative hypothesis. If it's assumption, if it's something that we hope for, if this is something that we assume, we put it in the null. If something that we hope for, or if something that we claim, or something that we need strong evidence for, we put it in alternative hypothesis. Most of the time, if you have a statement and you want to test to see if it's true or not, you should put it in the alternative hypothesis for most cases that we're dealing in this book, in this course, actually. Another different, I mean, I'll talk about the null, the difference between null and alternative in a separate video, but maybe just to quickly mention that null always contains equality, the sign of equality, and whereas alternative never contains the sign of equality. And these two are exactly the opposite of each other. Well, again, we will talk about the difference between the null and alternative and how we can develop null and alternative. Again, these are there is actually the same general rule applies to how we can develop null and alternative for different types of tests. Step 2, specify the level of significance. The level of significance is basically determine the error that you can tolerate, the error that you can accept. All right. So this is, again, we will talk about this one. We will talk about two different types of error that can happen when you're testing. When you are testing a hypothesis, when you're basically trying to see whether null or alternative is true. And we will talk about the level of significance specifically, which we also show by a notation alpha as the level of significance. It's very important. The third step would be to collect the sample and to get the sample data and find a test statistic. And this test statistic, again, is dependent on the type of the test that you're performing. So test statistic is different, but then the sample, hopefully this should be as random as possible. So ideally you should be looking for a simple random sample and then find the test statistic. Again, the test statistic, depending on the type of the test, it can be different. So we will talk about this one for each type of test that we're doing in this chapter. The next step would be to find the p-value based on the test statistic, the value of the test statistic. And p-value is actually the chance of observing results, test results, at least as extreme as the results that are actually observed in our sample, assuming that the null hypothesis is true. So I understand that it might be a little complicated right now, but we'll talk about that in this one later as well. The next step would be the conclusion step, when we basically compare p-value with the level of significance, p with alpha. Whenever we get a small p-value, whenever we get a smaller than alpha, p-value is smaller than alpha, in those cases we can reject the null hypothesis and we can take the alternative hypothesis. So when we are at the conclusion step, step 5, we either reject or not reject the null hypothesis. That's what we do. We have an assumption about our population parameter, null hypothesis. Again, I said this is the assumption. We either reject that or do not reject. We do not, here we're not proving anything. Everything, there can be error, right? We're taking random sample and there might be error. This is just to get enough evidence for action. It doesn't really prove anything, right? So we either, again, reject or not reject. We do not, this is not a proof. This is not accepting. We don't even use the term accepting the null hypothesis. And then the last step would be to interpret the result in a statistical term, in a managerial, in a business basically context.